this session, we recall some concepts of limit of a function, the conceptual background behind that. Before going to deal with the conceptual definition of limit of a function, let us first know or rebrush our knowledge regarding neighborhood of a point. Let small a be a real number. There is a point on the real line, that is real axis or x-axis. Now, you consider an open interval like this, which has been constructed by moving equal distance towards left and towards right also. Let this be a distance a 1, then this is the point a minus 1 and this is the point a plus 1. There the open interval a minus 1 to a plus 1 is called a neighborhood of a, centered at a of course, with radius 1 unit and length 2 units. Length of this neighborhood is 2 units. Again, consider a minus half to a plus half. What can we say about it? It is again another neighborhood of a with length 1 unit and radius half unit. And in general, a minus delta to a plus delta, of course delta is a positive real number, is called a neighborhood of a with radius delta and length 2 delta. This delta is arbitrary. This is called a neighborhood of a real number a. Okay, suppose we have deleted observe this set. The number a or the point a has been deleted from the neighborhood a minus delta to a plus delta. Then this set is referred to as a deleted neighborhood of a. Of course, with radius delta and length 2 delta. The central position of this neighborhood, that is the point a, has been deleted from this. Such a neighborhood is called a deleted neighborhood of a. One more example, you consider 1 minus delta to 1 plus delta is a neighborhood of 1, where delta is a positive real number which is supposed to be very small. Then this minus 1 is called a deleted neighborhood of 1. Another example, consider the interval 2 minus 0.1 to 2 plus 0.1 minus 2 is again another deleted neighborhood of 2. Deleted means what has been deleted and from what portion it has been deleted. From a neighborhood, the central part or the center of the neighborhood will be deleted and the remaining the set is of course called the deleted neighborhood of 2 here, deleted neighborhood of a. If you subtract a from this and deleted neighborhood of 1, this is deleted neighborhood of a it is. Well, in constructing these neighborhoods, is there any restriction, rule or regulation on the selection of delta? Not at all. Not at all. In general, the open interval a minus delta to a plus delta is called an arbitrary neighborhood of a, and open interval a minus delta to a plus delta minus singleton a is of course a general arbitrary deleted neighborhood of a. Now we shall discuss with the concept of the necessity of this considering these deleted neighborhoods. Suppose x belongs to a minus delta to a plus delta. What do you mean by that? X belongs to this neighborhood. What does it mean? X is in this space. If x is here. What is the distance between x and a? Mod x minus a. It is less than this distance, delta. That is mod x minus a is less than delta. Suppose x lies here. Even in this case, what is this distance? Mod x minus a. What is this distance? Delta. So mod x minus a is less than delta. Hence, these two statements are equivalent to be noted. X belongs to a minus delta to a plus delta, or mod x minus a less than delta are absolutely similar. These are one and the same. Suppose if I say 0 less than mod x minus a less than delta, what can we express this idea? What do you mean by 0 less than mod x minus a less than delta? First of all, everybody knows that mod x minus a is greater than or equal to 0. Here, the part is equal to 0 part has been restricted. That is, mod x minus a is not equal to 0 at all. That is, x is not equal to a. That is, x belongs to this interval, open interval a minus delta to a plus delta, and x is not equal to a. What do you mean by that? This is nothing but x belongs to open interval a minus delta to a plus delta minus singleton a. That is, x lies in the deleted neighborhood of a. Let us now make a review of this discussion. X belongs to the neighborhood of a means mod x minus a less than delta. X belongs to the deleted neighborhood of a means 0 less than mod x minus a less than delta. Now, again, let us focus our attention on this condition. What does this condition say? What can we learn from that? Zero less than mod x minus a less than delta means mod x minus a less than delta, and 0 less than that means x is in the deleted neighborhood of a. X is in the deleted neighborhood of a. That is, x may be here or x may be here. This point is a minus delta. This is a plus delta. Delta is a positive number which gives us the radius of this neighborhood or the length of this neighborhood. If delta is less than, this takes this form. Still less than, like this. Still less than, like this. For any delta, however delta small it may be, 0 less than mod x minus a less than delta, suppose I say. It means that x tends to a. X tends to a. The conceptual meaning 0 less than mod x minus a less than delta is denoted by the symbol x tends to a. In a similar way, if you want to say that f of x tends to some L, what must be had? The distance between f of x and minus L less than must be less than a very small number, isn't it? So, we are just coming very, very nearer to the conceptual definition of the limit of a function now. Let this be a function, say y is equal to f of x. Let this be a. Then what will be f of a? This is f of a. Let us represent a neighborhood around a like this. So this is neighborhood around A. That is nothing but open interval A minus delta to A plus delta. Let this be a real number, say L. This is below L. Let me call this some L minus epsilon. And let me call this L plus epsilon. What can we observe from this diagram? If x is here, where it will be f of x will be here. If you take x here, f of x will be here. If you take x, f of x will be here. So, for all those values of x between a minus delta to a plus delta, f of x will be in the interval L minus epsilon to L plus epsilon. What can you say from this figure? X belongs to open interval a minus delta to a plus delta implies f of x belongs to L minus epsilon to L plus epsilon. This we can say mod x minus a less than delta. That we can say mod f of x minus L less than epsilon. Right? If we say 0 less than mod x minus a less than delta, for every x in the deleted neighborhood of A, f of x is in the neighborhood of L minus epsilon to L plus epsilon. If such thing happens, then we say that f of x tends to L, or limit of f of x as x tends to A is equal to L. Limit of f of x as x tends to A is equal to L. Limit of f of x as x tends to A is equal to L. Right. Suppose x is restricted to lie here only. X is restricted to lie in this place, that is a minus delta to A only. Even then, if you are able to observe that mod f of x minus L less than epsilon, then that is x belongs to open interval a minus delta to A implies mod f of x minus L less than epsilon. Where does x lie? To the left of A. To the left of A. X tends to A from left, we say. Even then you are able to say that f of x minus L is less than epsilon. In this case, left hand limit of f of x at x is equal to A is L. If x is restricted to lie here, that is open interval A to A plus delta, then we say that right hand limit of f of x as x tends to A is L, or x tends to A from right. Yes. So, from this concept, from this diagram, we will be able to trace the meaning of limit of f of x as x tends to A, as x tends to A from left, as x tends to A from right also. Let us be brief in the mathematical expression of this left hand limit and right hand limit now. In the previous discussion, we did not mention the size of epsilon and delta. Epsilon is of course the radius of the neighborhood around L. Delta is the radius of the neighborhood around A. The actual concept involved in the definition is, for every epsilon greater than 0, there is delta greater than 0. That must be said in the beginning. What I mean to say is, to every epsilon greater than 0, there exists delta greater than 0 such that zero less than mod x minus a less than delta implies mod f of x minus L less than epsilon. What is to every epsilon greater than 0? What is the actual sense involved in that? To every neighborhood around L, there exists delta means there is a neighborhood around A. That is corresponding to the size of the neighborhood around L. The size of the neighborhood around A must depend. It depends such that for all those points x in this neighborhood, f of x will be in the neighborhood L minus epsilon to L plus epsilon. then limit of f of x as x tends to a is equal to L. This is the conceptual presentation of the limit of a function. Now, let me change very small items here. X belongs to a minus delta to a implies. What is the actual picture that can be viewed? That we can view from this sentence? X belongs to a minus delta to a. You can visualize it in your mind itself. A minus delta, this portion is the portion or the region behind A or the region to the left of A, and X is supposed to lie in that region. It does mean that X tends to A from left. X tends to A from left. In this case, we say that limit of f of x as x tends to A from left is equal to L. We are not supposed to read it as limit of f of x as x tends to a minus. That is not the proper way to read it. We are supposed to read it as limit of f of x as x tends to a from left is equal to L. There are so many ways to represent this also, like left hand limit at x is equal to a of f of x is L. Limit as x tends to a minus 0 of f of x is equal to L. Limit as h tends to 0 f of a minus h is equal to L. Of course, this is symbolic way. This is another way. And one more way is this. We can understand. We want to represent that x lies to the left of a. How can we justify or describe this pattern? What is that h? Why is it necessary to write like this? Let us imagine, let us think of, where does this x lie? A minus delta, x lies here. Let this be some x. X is behind a. It does mean that x is less than a or more than a. X is less than a surely. X is less than a means x is equal to some a minus h for some positive number h. H is basically a positive number. A minus h is strictly less than a. We are able to use a minus h in the place of x because x lies behind a, that is less than a. So a minus h. But you see, we want to write x tends to a, isn't it? X tends to a means a minus h tends to a means minus h tends to 0. That is h tends to 0. That is h tends to 0. Use this concept there. The left hand limit is going to be expressed as, in the place of x tends to a, we are writing h tends to 0, and in the place of x we are writing a minus h. Thereby this symbol is brought into use, under use, S. This is one of the ways of representing a left hand limit as x tends to a from left. Yes, there is another very brief way to represent this left hand limit. So many authors, so many students, so many lecturers also like to use this symbol f of a from left. What does it mean? It's just nothing but left hand limit of f of x as x tends to a from left. Left means who is left to whom? X is left to a. X is left to a. That is x is less than a. How much less than? Very few, very little quantity, say h. So x is of course a minus h. Well, this is the way of conceptual explanation of left hand limit. Now, let us observe some more, very few modifications to this definition. You please notice what kinds of changes that I have made here in this lengthier sentence. If to every epsilon greater than 0, there exists delta greater than 0 such that x belongs to a plus delta, open interval a to a plus delta, that is the right neighborhood of a. implies mod f of x minus L less than epsilon, then we say that limit of f of x as extends to a from right. Even though we write extends to a plus, you are not supposed to read it like extends to a plus. You must read it as extends to a from right. And it is of course called the right hand limit of f of x. RHL of f of x is L. And accordingly, this is similarly, this is as you could explain for a minus h, you can explain for a plus h also. Yes. How? Let us see. Where does x lie? In the open interval a to a plus delta. That is x is in the open interval a to a plus delta, that is the right neighborhood of a, that is a to a plus delta. Imagine x lies here, say here. What is the position of x? To the right of a, means more than a, that is a plus something. Therefore, we can write x as a plus h, where h is a small positive number. Surely x is more than a, so that it can be written as a plus something. That something is nothing but h. Therefore, we are able to express both left hand limit and right hand limit with the h concept like this. So, as before, in the place of x we write a plus h, and x tends to a. What does it mean? X tends to a. What does it mean? A plus h tends to a. That is, h tends to 0. And there is another way, brief way of expressing it like this. My dear friends, even though we write f of a plus, you are not supposed to read it like that. F of a from right. Right hand limit of f of x, or limit of f of x as extends to a from right. All of them give the same sense. Okay, so in this way we can explain left hand limit and right hand limit of a function and the limit of a function. So to have the right hand limit, x should lie between a and a plus delta. To have the left hand limit, x should lie between a minus delta and a. If you club these two, if x belongs to a minus delta to a plus delta, different from a, that is the deleted neighborhood of a, then we say that limit of f of x as extends to a is equal to L. Moreover, by summarizing all these things, we are able to frame the accurate and needy sentence like this. By summarizing the concept, we will be able to have the sentence like this. Observe the sentence very carefully. Limit of f of x as extends to a is equal to f L if and only if both the limit of f of x as extends to a from left and limit of f of x as extends to a from right do exist and are equal to L. That is, this must exist, this must exist, these two must be equal and equal to L. That is, this must exist and is equal to L. This exists and is equal to L. Then only we say that limit of f of x as extends to a is equal to L. If any one of them fails, that is, either left hand limit does not exist or right hand limit does not exist or both of them exist but not are equal or not equal, then in any of those cases we say that limit of f of x as x tends to a does not exist at all. Yes, well, that is limit as x tends to a, f of x is equal to L if and only if f of a from left is equal to L is equal to f of a from right. This is the concept of existence of a limit. That is, either f of a from left or f of a plus, that is f of a from right, do not exist, or they do exist but not equal to L. Then you say that limit of f of x as x tends to a does not exist at all. There will be so many such limits whose limits do not exist, and we come across in our way, of course, in the due course of time. Before going to deal with different kinds of limits, let us first observe some cases of functions for which limits do not exist. As an example, very simple function. Limit as x tends to 0 of root x. What do you say about this case? Limit as x tends to 0 of root x. Some students who are very early in their knowledge may believe that it is 0. Let us now see how far it is true. First of all, let me calculate left hand limit. What do you mean by left hand limit? Limit as x tends to 0 from left of root x. This is equal to limit as h tends to 0. Just now we have discussed that a one-sided limit, that is a left-hand limit, either a left-hand limit or a right-hand limit, could be calculated, could be estimated in h concept, that is limit as h tends to 0 f of a minus h. In the place of a we have here 0, so it is 0 minus h. What do you say about this? What is 0 minus h? It is minus h. It's a negative number under square root. Is it a real number? No, it's not a real number. Hence, does not exist at all. Does not exist at all. Therefore, no question of speaking of limit as x tends to 0 of root x. It does not exist. Why? Because both left hand limit and right hand limit should exist and they should become equal. But of course, here in this case, the left hand limit itself is not existing at all. Therefore, we say that limit as x tends to 0 of root x does not exist. Whereas, the right hand limit is equal to limit as x tends to 0 from right of root x is equal to, let us use the h conceptual limit. Limit as h tends to 0 root of 0 plus h is nothing but root h. It is 0. Observe the case here. For this function, right hand limit is existing, left hand limit does not exist. Therefore, this limit does not exist at all. Okay? This is the way in which we notice the left hand limit and right hand limit. To calculate the left hand limit, we have to believe that x lies to the left of a or left of 0 here. Therefore, it is 0 minus h. Hence, root of 0 minus h does not is not meaningful in real numbers. Therefore, it does not exist. Whereas limit as x tends to 0 from right of root x, we can easily see and say that it is 0. Okay? Yes. One more example let us see. This is the function. This is the function. Of course, we may recall that this function is named as some people read it as signum function, or some people read it as sine function, not S-I-N-E, S-I-G-N, as you like it. Yes, whatever you call it, this is the function under discussion. What is our responsibility? We are supposed to examine, we are supposed to check whether that limit exists or not. Let us first simplify or understand the nature of the function f of x. F of x is equal to what happens when x greater than 0, what happens when x is equal to 0, what happens when x less than 0. Now you tell me, if x is greater than 0, everybody knows that mod x is x, that is x is greater than 0 implies mod x is x. Therefore x by x is 1. If x is 0, he himself has given that it is 0. And if x is less than 0, what does it mean? If x is less than 0, what is mod x? Minus x. So it is minus x by x is minus 1. Well, we have not calculated the limits at all. We have just seen the nature of the function. How does it behave in different regions? Now let us see. It is a very easy matter to go through the limits. It is a very easy matter. Well, let me first calculate limit of f of x as x tends to 0 from left. What does it mean? X tends to 0 from left. That is, x lies behind x, 0. That is to the left of 0. Means less than 0 or greater than 0? Less than 0. When x less than 0, what is f of x? Minus 1. Hence the answer is minus 1. Limit of f of x as x tends to 0 from right. What do you say about this? Where does x lie? X tends to 0 from right. That is, x is greater than 0. If x is greater than 0, what is the weight of f of x? It is 1. Therefore, it is 1. What can you say? Left hand limit is minus 1. Right hand limit is plus 1. Both of them do exist but are not equal. Therefore, f of 0 from left is not equal to f of 0 from right. Therefore, limit of f of x as x tends to 0 does not exist. In the previous example, we have seen that one of the one-sided limits, that is left hand limit, does not exist. But here both left hand limit and right hand limits do exist but are not equal. In this case also, we say that limit of f of x as x tends to 0 does not exist. Let us examine one more example. Consider this example. A new function before us. F of x is x square plus 1 if x is less than 0. 1 minus x square if x is greater than 0. What have you observed here? What about f of 0? What about f of 0? The function f is not defined at x equal to 0. At x equal to 0, the function is not defined at all. Then, is it possible to discuss the limit of f of x? Why not? Why not? We can discuss with. Why? Because if you go through the conceptual definition of a limit, 0 less than mod x minus a less than delta implies. That is, x lies in the neighborhood of a but not equal to a. It is in the deleted neighborhood of a. So, we are not bothered about the definition of f of a. It is just immaterial even if the function f is defined at x is equal to a or not. This is the best example for that consequence, that type of situation. The function f is not defined at x equal to 0 here at all. Of course, in the left region it is defined, it is the right region, the region to the right of 0 it has been defined. Let us see whether the limit do exist or not. First of all, left hand limit is equal to, what is the left hand limit? Limit as x tends to 0 from left of f of x. Where does x lie? To the left of 0. That is less than 0 or greater than 0? Less than 0. In less than, if x less than 0, what is the definition of f of x? X square plus 1. As x tends to 0, this tends to 0 square plus 1, that is 1. Again, right hand limit. What do you say about right hand limit? Limit as x tends to 0 from right of f of x. In this scene, in this situation, where does x lie? To the right of 0. That is more than 0 or less than 0? Surely more than 0. X greater than 0. In this situation, the definition is 1 minus x square. Hence, the limit becomes 1 minus 0 square, that is 1. Here, both f of 0 from left, f of 0 from right are equal. Both are equal to 1. Isn't it? Astonishing. The function f is not defined at x equal to 0. Even then, limit of f of x as x tends to 0 exists and is equal to 1. This example makes us to remember or to recall the knowledge that existence of limit of f of x as x tends to a is purely immaterial about the definition of f of a. We need not bother about whether the function f is defined at x equal to a or not. We have seen here in this example, the function f is not defined at x equal to 0. Even then, limit of f of x as x tends to 0 is existing. The answer is 1. Well, this is a beautiful example. Let us see one more example. Let us consider the function which has been written on the board. You might have recollected that. It is written as integral part of x or step function of x or greatest integer less than or equal to x, like that. In so many ways you can read it. In fact, let us choose one of the ways of pronouncing it. Say integral part of x. What do you mean by integral part of x? Let us recall. You see, 1, 2, 3, 0, like that. Suppose there is a point like this here. Let it be some 1.6. 1.6 is, what do you mean by integral part of 1.6? Here are 1.6 is nothing but 1 plus 0.6. 1 is integer, 0.6 is fraction. Therefore, this is equal to 1. Integral part of 1.6 is 1. And what do you say 0.6? 0.6 is fractional part of 1.6. That is, there has been another symbol also for that to represent the fractional part. What is that? You need not, you are not supposed to read this is as flower bracket 1.6 or singleton 1.6. Singletons at 1.6, it is not the way to pronounce. This is fractional part of 1.6 is nothing but 0.6. If you add these two, what you have? Integral part of x plus fractional part of x gives you x. Integral part of x plus fractional part of x gives you x. Suppose let some point will be here. What is the integral part of this? 0. What is the integral part of a number which like here? 2. What is the integral part of 1? 1 itself is an integer, hence the integral part is 1. What is the integral part of 3? 3. Integral part of 2? 2. Integral part of 1.99999999999 but not 2. Integral part of 2.00000000001 2. Isn't it? This is the nature of this function, that is integral part of x. Okay, what do you say about limit as x tends to 2 of integral part of x? Let us see the nature of left hand limit, that is limit as x tends to 2 from left of x. Without using much steps, we can read the answer directly. where does x lie? To the left of 2. To the left of 2 means less than 2 or greater than 2. Less than 2. Where does x lie? There, just behind 2. How can you imagine? It can be 1.99999999999. That's all. It is not 2. It is very nearer to 2 and to the left of 2. So, whatever might be the value of x, as it is very nearer to 2 and to the left of 2, integral part of x is 1. Is 1. Hence, left hand limit is 1, whereas right hand limit is limit as extends to 2 from right of integral part of x. What do you say about that? In considering this limit, where should x lie? X lies here, say. So, what can you imagine in the place of x? More than 2. Very nearer to 2. That is to the right of 2. So, it can take the value at most 2.00001 like that. In that case, what is the integral part of that? 2. Hence, it is 2. Anybody can say without putting any effort or step that LHL and RHL are not equal here. Therefore, limit of f of x does not exist at all. Limit of f of x as extends to 2 does not exist. Okay. If I change this 2 to 1 by 2, what happens? Half is a fraction. Lies between 0 and 1. This is half. To the left of half means somewhere else here. Half is 0.5, 0.5. To the left of 0.5 means 0.499999999. But not 0.5. Even then its integral part is 0. You are pronouncing it as 0.4, 0 point something, isn't it? Integral part is 0. Integral part is 0. Okay. Hence it is 0. What is about the right hand limit? Right hand limit means x tends to half from right side. That is, it should lie. It is supposed to lie to the right of half. Means more than half. That is, it may lie somewhere else here. Exact point is half. That is 0.5. More than that means 0.5001, 0.0500000001 like that. Even for that point also, the integral part is 0. What do you say here? Both the left hand limit and right hand limit are equal and they are equal to 0. Equal to 0. By observing these two cases, we will be able to generalize a particular result regarding this.